Welcome back to Classic Car Restoration. Today we're adding some more thunder to our 62 Thunderbird Sports Roadsters 390 cubic inch V8. Now, while there were a variety of aftermarket aluminum heads available for the Ford 390 motor, we've chosen a set of Edelbrock Performer RPMs. They're 20 pounds lighter than the cast iron heads. They feature more efficient intake and exhaust ports. They have stainless steel valves which are larger than stock, and they also include hardened valve seats on the intake and exhaust seats. That means you don't have to worry about unleaded fuel, which used to be a big problem with our Thunderbird's original iron heads. Before we can install the new cylinder heads, we have to install new cylinder head gaskets. Now, you always want to look at the gasket to see if there's any kind of instruction. In this case, they say front. We want to be sure that we put this end toward the front of the car. Otherwise, they could be installed upside down, which could lead to failure. Now, because these are Permatorque type gaskets, there's no need to spray these with any kind of a lacquer. That's from the old days. These gaskets are ready to go. Want to be certain that we have nothing sticking to the bottom of our brand new cylinder heads. They're clean. Let's put them on. And the new cylinder head goes on, seating it in place on the head dowel pins. To clamp our fresh cylinder heads to the block, we're not going to rely on the old bolts. Instead, we get new ones. And to keep them from galling in the block, we'll apply some thread sealer compound to the threads, and then hardened washers underneath the shoulder of the bolt. These will keep the bolt from galling the aluminum as they're torqued down. I install the bolts by hand at first, and then we'll torque them down. Cylinder heads have to be torqued down in a specific pattern. You've got to have a torque wrench for the job. Now, in the case of these aluminum heads, because they're made of a soft alloy versus cast iron, which is much harder, we're going to go 3 steps instead of the usual 2. We have long bolts and short bolts. We'll go 70, 80, and 90 on the long bolts, and on the short ones, 60, 80, and 90. Once again, 90 being our full torqued mode. Now, according to our Ford factory specifications, we start at the center and work our way out. So, with our torque wrench set at 60 pounds, we'll go to the bottom center bolt and begin. And I torque the bottom bolt down to the first step of 60 foot-pounds. Then I set the torque wrench to 70 foot-pounds and then torque the top center long bolt. I'll continue with this process until all the bolts are properly torqued. Next, we move on to the rocker arm assemblies. The manufacturer of these aftermarket cylinder heads recommends mocking up the valve train to ensure proper valve tip to rocker arm tip alignment. We can see here in our mock-up that we've got a misalignment, a very slight one here, on every intake rocker. Now, that's because the manufacturer of these heads moved the intake valves outboard a little bit to get better flow. No problem, we can fix it. What we do is we disassemble the entire rocker shaft assembly and add a 60 thousandths valve spring shim, basically in this location right here. That reestablishes proper alignment between the rocker and the tip and gets us off the hook. When we come back, we'll install a new aluminum intake manifold and the modified rocker arm assemblies. Welcome back to Classic Car Restoration. Now it's time to install the intake manifold. Now, just like the cylinder heads, we want to be sure there's no grease or debris that'll keep the manifold gaskets from sealing. We don't want to forget the oil splash barrier, which goes beneath the intake manifold. It just sort of snaps right into place. Now, the gasket end seals that we get in our kit have adhesive backing, so these are actually going to stick down to the cylinder block. Again, that's why we have to clean the block to make sure that it's absolutely free of grease. Now, the gaskets themselves go on. And to prevent leaks at the corners of the manifold where it meets the block and the heads, we'll use some clear RTV sealant and just make a little blob right here in the corners in all 4 positions. When this stuff dries, we can trim away any excess so it's not as unsightly. Now it's time to install our beautiful aluminum intake manifold. You may need to adjust the gaskets so they lay flat and straight, and the intake manifold sits snug against the heads. Now again, we're threading into aluminum, so it's important to use some anti-seize compound to prevent galling of the threads. The intake manifold bolts go in, as always, by hand at first to ensure that they are threaded properly. Then I can use the socket wrench to just tighten them to hand tight without actually compressing the gasket. With the intake manifolds finger tight in the manifold, now we're ready to tighten them. We'll be using a spider pattern. What does that mean? It means basically working from the center outboard like this. We start here, snug that one, go to the next, snug that one, up here, snug that one. Work from bank to bank to evenly distribute the clamping load on the manifold. Now in the situation of our Thunderbird, we're going to be reusing the stock push rods. So to make sure that they're straight and flat rather than bent, we'll take them and roll them on a flat surface like this piece of plastic. We'll do them one at a time. And if any one of them exhibits a bow, we've got to replace it because that's a bent push rod that will cause inaccurate valve timing. Okay, now we'll put the push rods in place, and I always like to put a little bit of white lithium grease on the end of the push rod so that when we start the motor up again, it doesn't have a dry start. And we want to put these in, make sure they're seated in the lifters. Now with the push rods in, we have to now make the connection between the camshaft and the valve spring, and of course that means the rocker arms. But to prevent dry starts and wear, let's put some lube on the tips of the valves, like this here. And again, we'll put some on the push rods. Again, just to keep this dry stuff from running without lubrication for the first few minutes. Then I install the rocker assembly. I use a straight piece of wire, a cut coat hanger will do, to hold the push rods up and out of the way so I can line up the rocker assembly. When we tighten down the rocker arm shaft, we want to start from the center and work our way out. It is possible to bend these things because of the valve spring pressure and when the camshaft is up on a lobe. So we want to bring it down real easy, evenly from the center out. We have a tough decision to make when it comes to the valve covers. Now, this is a pretty rare car, and we have the original valve covers that are stamped Thunderbird, which are actually kind of collectible. Some people pay good money for these. Or we can go with these cool chrome valve covers and look like a hot rod. I say let's go with the chrome covers. We can always put these things back on. It's no harder than changing sneakers, so on with the chrome valve covers. Now the fasteners, once again, these have to be coated with some anti-seize compound because we are threading into aluminum on these cylinder heads. Well, that looks great. When we come back, we'll install the high-performance 4-barrel carburetor. Welcome back to Classic Car Restoration. Our Thunderbird's original 4-barrel carburetor is an Autolite piece, and it's not exactly for high performance, so we're going to upgrade. In its place, we're going to install a 600 CFM 4-barrel carburetor. Now, you may be wondering, what does 600 CFM mean? Well, CFM stands for cubic feet per minute, and 600 is the rating that this carburetor flows at wide open throttle. That's plenty enough for our 390 Thunderbird motor. I start by installing the carburetor studs onto the new intake manifold. On with the fresh gasket. And now it's time to install the new carburetor. We want to be sure that we don't have anything on the bottom here, so we'll just wipe it off. And then we'll roll it over and set it down on the motor, like so. It's held down by 4 nuts. So what we'll do is very gently make the rounds in sort of a crisscross pattern, pulling the carburetor down a little bit as we go. And just snug them down so there's a good tightness. And that's that. Now we begin connecting the engine and the carburetor to the rest of the car. The accelerator rod is attached to the carburetor and held in place using a cotter pin. And now we put the bell crank bracket into place on the manifold. It's nice how this manifold actually has raised bosses that are drilled and tapped to accept all the stock parts. That's nice engineering on the part of the manufacturer. Here's the throttle return spring. We put this to the bracket on the carburetor, and then we hook into the bell crank. Next up comes the secondary throttle return spring, which goes to the lower bracket. And then we test the throttle by stepping on the gas pedal to make sure that it's reaching full travel. Next is our heater hose supply, and that's going to involve basically some things we'll have to get at the hardware store, some brass fittings, and in the case of this one, we've got a 90-degree union, I guess we call that. Tighten this baby in. And then into the end of that, we put a nipple, which again comes from the hardware store. Okay, we tighten these things up. Now these are all pipe thread fittings, so we just snug them down so that they're bound. Next up is our temperature gauge sending unit. We want to be sure to get one of these from the parts store. They're a very common item. And finally, we install a vacuum tee, which will provide vacuum to the powered brake booster and allow the powered brakes to work. Now, our 4-barrel manifold that we've replaced has an entirely different fuel inlet location, so our man Keller came up with this beautifully made replica of the stock one, but it has a little more kick out and comes down to meet the new carburetor, although it still attaches to the fuel pump in the same way. We made our new carburetor to fuel pump fuel line using standard 5/16 steel fuel line. We used a tubing bender to create the shape that we needed. It's kind of a funny thing. Our new induction system allows this Thunderbird to actually run cleaner. How's that? Well, the original intake had a road draft tube, which basically let crankcase ventilation get out into the atmosphere. Well, this new setup actually has a PCV valve, a positive crankcase ventilation valve, which goes from the carburetor to the passenger side valve cover. And believe it or not, this is actually going to reduce emissions. Then I replaced our old heater hoses with new ones. These are 5/8" heater hoses that have been cut to length. And then this comes up to the intake manifold, to the fitting we've just installed here. Now we tighten our clamp. Now the original manifold vacuum hose was in pretty bad shape. You can see it's broken. There's probably no doubt that this wasn't functioning right, so we'll get rid of that with a fresh piece of vacuum hose. It'll run down like this and connect up. Our final rubber hose connection goes to the power brake booster. Now we can install the distributor. The intake manifold comes with a fresh distributor seal, and we can see here that the one that was already on our car is, look at that, it's cracked, and well, that's an oil leaker. So we'll get rid of that and we'll put the new one on. We'll just sort of wiggle it up on here, work it into place. And on it goes. Put the distributor in place. And I connect the vacuum advance line that goes from the bottom of the carburetor to the distributor. And the distributor hold-down bracket goes into place and gets tightened down. The radiator surge tank goes back on and gets tightened down, and the hose is reattached to the radiator. Next up comes the air conditioning compressor stand, and again, it's a nice thing. The manufacturer of these heads has holes drilled conveniently right where this thing needs to go. Great engineering. Now we roll the air conditioning compressor right down onto its mount, like this, and I bolt the compressor down to the mounting plate. Now we install the wiring harness to the engine. The first wire comes from the wire harness and is hooked up to the positive ignition coil terminal. Next is the negative coil wire, which comes from the distributor. I make sure that each wire is secured to the coil terminals. Then I hook up the air compressor activation wire, and then the temperature sending unit, which goes into the car and to the gauge on the dashboard. And finally, I hook up the oil pressure sending unit. To activate the electric choke on our carburetor, we have to have switched 12-volt current coming to this wire here. Then the distributor cap goes back onto the distributor and locks in place. And I can route the spark plug wires to each side of the engine and plug them into their corresponding spark plugs. Then the distributor cap is connected to the coil. Well, with these new parts on our Thunderbird's 390 motor, we've probably bumped the horsepower from 300 to about 350. We're going to feel that in the seat of the pants. And because we've added the PCV system, we're going to have cleaner emissions to boot. As always, resources and information from this show are available on our website at DIYnetwork.com.